Mistaken, and there's like another conference going on right now that deals with plumbing.
Louder! Talking balls!
Hello! Is that good? Okay. Excellent. Today's talk is on, all right, so hey, as Squeak mentioned in the intros are weird, I'm Evan. It's been a while since I've been here. Can everybody hear me? Everybody good? Excellent. Cool. So yeah, you know, we haven't talked in a while, so I thought maybe you'd like to just get together and discuss a few things and perhaps talk about everything specifically that can kill you. Fade to title slide. I haven't slept a lot at all this week, so it's going to be fun. My name is Evan Booth. I'm Evan Booth on Twitter. I'm also Evan Booth on Earth as a human man. I work for Skookum, as Squeak mentioned. Something that I've been doing in my talks in the beginning, before I get to sort of the main subject matter, is a little... Did you say squid vagina? Rorschach is blowing up my phone right now. He wants to talk to you. Wow. All right, so this is good. I'm going to go long, by the way. I'm sorry in advance. I'm not sorry. It's going to be good. I've been doing this thing called the shotgun of random, and this is sort of ideas that kind of come to me here and there, and some ideas they bounce around for a long time and they don't leave. And so really this is just a service to myself. I'm forcing them on you in rapid succession, that's a word. So yeah, here we go. All right, that's nice and loud enough. I think it'd be an amazing prank if, like, in the city somewhere, like someone walking a lot of dogs was, trucking along, wait till someone like got right behind them, and then they would turn a corner, and then like a couple seconds later scream, and then reemerge around the corner with this look of twisted horror on their face, and then in their other hand would be holding a bunch of leashes with inflatable like balloon animals. That's going to be a Japanese game show soon. And that's the shotgun of random. All right, so yeah, I got glasses exactly 1 week ago today. And so if I'm like doing things like Will Ferrell in that movie with one of the race cars, yeah, so yeah, I'm still getting used to this, like Bambi walking. So yeah, excuse that. On the plus side though, my wife said that my glasses make me look less threatening. That is an exact quote, less threatening. Plus now, when I have glasses, I can talk about the things. You know the thing about Scotch. You know the thing about hitting a man with a battery in a sock? And you just start, and then people cling on every word. They're like, I'm ready for my quiz bowl fodder. Here we go.
It's unwise of me to share these details, but I've become inebriated.
All right. Somebody make an observation about this photo. What's going on? Something's wonky about this. You guys are, there's nobody jumped. How would you know that? We're all gonna die. Is it slanted? Why is that concrete slanted? You guys don't know? This is awesome. I'm so glad I get to tell you this. Okay, so so I am in a car moving, right? Taking this photo safely out of the window. And what you're seeing here is a result of what's called a rolling shutter, right? A lot of CMOS sensors, they use this, and usually in like lower end digital cameras and a lot of phones and stuff like that. And instead of, they expose the entire sensor to the scene, the light, right? But instead of reading data from the whole thing, the whole image, like a high-end DSLR might, they read line by line, right? And they do that because it decreases bottlenecks and data, better for battery life. It helps you take pictures faster in rapid succession. But that does mean that by the time you finish taking a photo and collecting all the lines from the sensor, the photo is changed. Like, this scene is different, especially if you're moving or something that you're shooting is moving quickly, right? So it works like this. You guys ever see this, like online or on Reddit? Like, that's a rolling shutter. Basically, you're capturing a period of time very quickly, but you could see that in these photos. Videos as well, obviously. Really cool stuff. So, the shotgun of random aspect of this is that I wish that someone, I wish I would, but I also wish that I had a lot more time, would come along and write a piece of software that would take and consume a photo like this and look at the EXIF data, right? So like camera model, specifics, sensor type, the ratio, geolocation, all that stuff, right? Zoom level. Add that with the characteristics about that rolling shutter that they know about, right? They're fixed. And then maybe throw like a neural network on top of that. So maybe over time have a computer be able to say, this looks like a rolling shutter distortion here. And then add that to all of the math, basically. And so you could take a photo like this, and looking at this particular section, you know that this is supposed to be perpendicular, right? These concrete slabs. But we know that the distance or represented between these two lines is a measure of time, right? Because we know that the rolling shutter, captured all that, in between like that. So that's a known amount of time based on the shutter speed and the characteristics of the rolling shutter. So we also know that we have a degree of skew, right? And so with that information, like, you're able to eventually, right, looking at that and then comparing that to other subjects in the photo, really start to pull out information about how fast the camera was moving at that point in time, right? What is the bearing? Where's it going? What are the winning lotto numbers? That's a bald-faced lie. But also the stuff in the photo, right? Because, parallax is a thing. Obviously, things that are further away are going to be moving slower in your viewfinder. They're going to be less affected by the rolling shutter. So if you're able to measure that relative to something else, all of a sudden you can start mapping out where things are relative in 3D space, right? How fast are they moving, if they're moving at all, or whatever. And like rolling shutters have been used for a long, long time. So there's a lot of pictures and video and all that stuff that we could probably run through some algorithms and get some really interesting additional information behind that. Someone should do that. Cool. So these protocols are a thing, and companies are using these to spin up home automation hubs, right? Lots of them. Competition is growing and growing, and eventually this hardware will become inexpensive enough such that new construction will start to fold it in because it makes sense, right? Most people will have it. Now, eventually, one of you jokers are going to find a really nasty vulnerability, like RCE or something like that, in one of the low-level libraries that one of these things uses, and you'll find yourself one evening being like, oh, I can control all the stuff in a lot of people's houses, right? So lighting, AV, your HVAC, door locks, all this stuff could potentially be open. So if it's one of you, right, and this happens, make the right choice and pick a random night and then and do this. Murder night, yeah! Woo! Hey man, did you get murdered last night? Yeah, it was awesome. And also this. Do the right thing. Moving on. All right, show of hands. Who has been completely and utterly screwed by the lack of inflection available in text-based communications? A lot of people. So there are a few ways to show emphasis in text. You could italicize, you could make things bold, you could change color, kern things out, underline it, do all the things. Like, this stuff's been around though for a long, long time, right? And so we over time, as we did more and more communicating over this medium, we started to improvise, right? So we started doing this, and this is interesting to me because we MacGyvered stuff right? We found a Q-tip and a tube sock, right? And you're like, oh look, now I'm pissed. Or like, look, now everyone knows I'm really sketched out right now, right? Or I'm looking at you disapprovingly because of, you know, this character in Unicode. And like, and people have started adopting this, like, you know? And it gets really crazy, you know? Jokers are flipping over tables. And then dude's like, dude, calm down, man. No. And we've done this for a long time. It's okay. And then this happened. Man, yeah. Whew, that's hard to look at. So there are some lesser known conventions as well. You know, Reddit has the nested superscript, you know, and you know B has green text, right? So this is all good. Like we've done a pretty decent job with all this stuff. But consider this, like, does anyone know when the first commercially available typewriter was introduced to the market? Anybody? It was 1873. And if you do some math, that's 143 years, right? Now that's typewriters, right? So if you just look at like more digital, you know, real-time communication that's, you know, text-based, that's still like, what, 50 years, right? And in 50 years, or 143 years, however you're measuring, if I want to make darn sure that the person I'm talking to knows I'm being sarcastic, what do? Great job, everybody. We've done a great job. So, I think that if someone took even like a poor attempt at solving this problem, like, I think we'd land in a better place, right? Our phones, our devices, like most of them are fitness trackers now, they know how we're feeling, right? To some degree, and that'll only improve over time. Like if I run up like, 10 flights of steps and I'm texting someone, like I want them to know that, right? I'm sorry, I'm misspelling everything, but like, you know, I don't know. I think it's an interesting space. Moving on. Somebody needs to make a little pack of like little stickers of various sizes and stuff, and maybe like some with like some chrome around it, and then like maybe some that say like motion activated, so I can run around snickering, placing them on things that are not. I don't. I would be in the stall. It's like, yeah. All right. Popular movie and television logic dictates that if someone like shoots the DJ or the DJ runs off, the music stops. As if they are wearing some kind of like jet ski, frickin' treadmill, wrist strap thing. That is not how that works, guys. The music keeps going. You're stuck within you or whatever it is. Okay, so this next one's great if you want to make a lot of money, but you hate everything and everyone. So someone needs to make a pair of like really unique pants. And if anyone owns these pants, this is just an example, right? Someone needs to make a pair of pants that is like unique for every single pair sold, of course, because they'd be like $5,000, $10,000, right? But on top of that, you can't purchase these pants unless you take this extensive, physical assessment, and you are ranked in the 98th or 99th percentile of attractiveness, right? They're hot pants. Tell your friends. Yeah. So you have this, right, the hot pants. Not only that, you would have to come back and be reevaluated, every 12 months or something like that, right? This would be like Mensa for vapid jackasses, right? And you would have to sign a contract to this effect, right? And buried somewhere deep within the contract, it would say, look, if you get a little sketchy and like sell or give away your pants, we'll burn your house down. Tell your friends. You guys know these like blimps and like playing around and stuff around like sporting events, conferences, all that? All right, someone needs to take and put a little box on the belly of it with a little like trap door. It opens like randomly and just drops out glasses to help people deal with things. I'm feeling better. So if you see the Secret Service agent doing this, you might think that he's like listening to his earpiece, to someone else somewhere far away. But actually, this is what's happening. Yeah. Yeah. Okay. Here are a few ways that machines express inequality. Here are a few ways that humans express inequality. I wasn't expecting laughter. I'm not telling you anything new, and I don't really have a grander point, except to say, this movie, that might have been the good guy. I'm just saying. Throwing that out there. Forget I said that. All right. You guys know the Doppler effect, right? Why has someone not invented a speaker, right, that tracks the car and tracks the velocity and the trajectory and all that stuff, and like sends a message, but adjusts it, like just the pitch and the volume based on where they are, so it comes through in their car. It's like one like continuous, steady audio signal, right? Like all of your friends know. And then the driver poops. Oh, okay, we're out. We're good. So that was the shotgun of random. You guys enjoyed that? You guys like that? Okay. So, getting down to business a little bit. One thing that's always really fascinated me was the fact that throughout history, some things, some products or whatever the case may be, some of them like really find like a lot of use in a very wide variety of markets and applications, right? And this could be like a completely natural product or something that we make or whatever, and it could happen for a number of reasons. And I think really it kind of boils down to this, like some things we've like as a race or a species, we've really asked the question, like, what's the full potential of this thing? And that's something that like just like I get really excited even saying it, right? That's a really interesting question to me, and like we've asked that about some things over time. Now, a lot of the times when we do ask that question, there are financial motivations, and it's advantageous to do so. So, like how many transistors can we fit on a wafer of silicone, right? That's how can we organize plastic to make it the most structurally sound, right? Now, the most interesting examples for me are the ones that have either or motivations that are either rooted in passion or necessity, right? And two that come to mind, of course, the first being Mr. George Washington Carver. And you guys are familiar with George Washington Carver, yeah? So I was thinking about George Washington Carver, and I was thinking about like it started doing a little research and stuff. I was like, you know what? I have like the third grade book report of George Washington Carver in my head, and like that's pretty much it. So it's like bullet points that are okay for third graders. And like, well, that kind of captures the general idea and stuff. It's really interesting to go back through and look at it with a more adult perspective and stuff. So there's like different things, that you pull out and more, appreciate more, just whatever. But anyways, we all know George Washington Carver did a lot of work on peanuts, right? He really looked at a peanut and like what's the full potential of this tiny little thing? And as you know, he had great success with that. Also, maybe a little known fact is George Washington Carver, when he got to a new university to assume a teaching role, realized that they had no lab equipment whatsoever. That joker, he went to a junkyard and just found stuff and made one. He's just like, I'm gonna go make a lab, right? But that's who he was as a person. He really had a passion for education, passion for teaching. Like a lot of the like, there's really two primary drivers behind how he accomplished so much in his lifetime. You would have think he lived 500 years, but he really loved nature. Like he spent time in it as a kid and loved it, drew it, like started painting it and all this stuff, and he was just fascinated with it, right? And the other thing is he really had a passion for like one horse poor farmers. He wanted to help them, understand, like, well, how do I maximize what I can do with what I have, And that's the whole full potential thing. So he made a couple of things with peanuts. And it's, yeah, that's my favorite. All right. So yeah, George Washington Carver. It's fantastic. Did he make hot pants? He made peanut pants. It's just a list. Don't ask questions. Maybe I was typing out a shopping list while I did this. Rash cream. Well, he actually may have made that. Yeah, I saw that. Like, give me some of that peanut flavored nitroglycerin, please. So yeah,
So is your next talk going to be about how you can blow up an airplane with peanuts?
maybe, I don't know. We'll see. All right, so George Washington Carver, fantastic individual. Like, the dude's brilliant. And a great example of like what can happen when someone asks the question, like, what is the full potential of that thing? And the next example comes from Cuba. And as you know, Eisenhower, he imposed a trade embargo on Cuba in 1960, and then in '91, I think 80% of their oil imports dried up, and like their economy just got kicked in the face, right? And so all of a sudden we can't buy things. It's like more or less illegal to own or have possessions and really deviate from what everyone else has, right? And I'm in the explain it like I'm 5 category as far as that goes. So citation needed there, but that's my understanding. But what I do know is that because of that particular set of constraints, the whole country basically has had to be very, very creative about what they have, using it to accomplish, basic life stuff, right? And of course, Castro spun this whole thing as the special period in time of peace, which is probably the most hand-wavy sentence I've ever read in my life. But I mean, they made some amazing stuff, and this is how it works. So they would take a bike, like a Frankenstein monster bike, strap a motor on it, and call it a Rickenbelly, right? And cruise around in that thing. That's amazing.
Is the gas tank a 2 liter?
It is a 2-liter bottle. Ride fast, my friend. This thing recharges hearing aid batteries and also kills you. Surprise! Yeah, I don't have to hear anymore. But they couldn't recharge their batteries. They're like, well, what do we do? We'll do this. Great idea, Steve. It's working, though. Thing on the left is a flywheel-powered motor starter. So basically, they drop a weight, gets that wheel spinning, and they use that to start engines, because starters fail, right? Can't have that. Gravity doesn't fail very often. And on the right, there's a home-brewed irrigation system with, bottles and PVC. And
Hello. Hello. Here you go.
Anybody have a 2-liter bottle? Okay. We good? All right. Cool. Food trays. These are government issued food trays, right? Or government issued. Hello. You good? A little louder. This one's a little quieter. Hello. Good? You good? I don't know. I sound the same to me. Like a muffled nothing, really. All right. So yeah, these are food trays. People use them as antennas, right? Absolutely amazing. And the skyline is littered with these things because that's what everyone does. And it's really kind of created a whole industry for people who can jerry-rig the stuff that they have. And the government sort of again, kind of hand-waving, they got in on this and they put out a publication called The Book for the Family. And it was basically kind of a compilation of popular mechanics and a bunch of how-to guides and stuff like that on how to use the stuff you had to make things happen, right? Because they were trying to make it a good thing. Yay! Like parents do for toddlers. I know you don't want to do this. Let's make a game out of it, right? Yeah, I don't really. No, that's very accurate. And they followed it up with this. It's like .com, .org, .biz. They followed it up with this, and like basically these things, this was a 300-page manual, just jam-packed full of like anarchist cookbook recipes, right? So like there's what is this? What's this thing? Transformer, thank you. This is a pattern for some kind of doll with like an unsettling amount of attention paid to the nipple area. I seriously like looked at this for about 5 minutes and like, why would anyone need to do this? And then I realized I probably need to learn to speak Spanish. But is it really? Someone said an underwear guide? Oh, that makes a lot more sense then. Moving right along. We don't need to unravel all of life's mysteries here tonight. We could save a few. This appears to be plans to build a very rudimentary kill yourself device. This is a gun on a stick or something. I don't know. Like I would imagine this is maybe for sighting or like zeroing or something. But like then like there are electrical leads right here, and like this does a thing, and I don't even know, man. My favorite though is probably the deplasmatizador, whereby you take settled Italian dressing, don't shake it. And then you take a needle in that and put it over here in these two jars with ghosts in them or something. And then of course, you run that line over to the motor from a refrigerator and then plug that into the wall. The plasmatizador. Of course. So people are making do with what they have. One of the standout items that you'll always find is the Eureka washer/dryer. And this sort of became more the Eureka washer because the dryer would always crap out. And something else that fascinates me about electronics specifically is like it's not just a boombox or who has boomboxes? Great example, Evan. Fantastic. It's not just an appliance or something. It's a bunch of crap inside that all has like various life cycles, right? So like you could have a lot of really good stuff still left in your broken thing, and they realized this, and so every single one of these that crapped out, they would just cut it right down the middle. We'll keep the washer, right? The dryer, we're going to use that motor for everything else, right? And it became a thing, and this actually made it into the By Your Own Efforts guide, right? How to use your dryer motor for a bunch of stuff. This one shreds coconut, right? This is an automated key duplicator. Crazy things. This is a slanty thing. I don't know what it is. I think it's doing it like a boss. This is a shoe polisher, right? All from the same motor. This is a boat propeller attached to the motor, attached to what looks like a brick, but it's a battery. Tricky, but it's a fan, right? Like we've got this stuff. Let's make some functional stuff out of it with the stuff we have. I love it. Right. So that stuff's fascinating to me. It's people that had to, either because of necessity or because they were just passionate about it, really like dug into an item and said, okay, what all can we do with this thing? So, sort of with that passion mixed with sort of an officer what? No, it's black. It's a black slide. Intentional. See? Is the fan better? We'll stop on the fan. Okay. So that wasn't that fun. So I started thinking about this, and also thinking about the fact that like we're becoming more and more dependent on things that are powered with electricity, and not becoming more and more familiar with how electricity works, just on a fundamental level, right? So that's problematic. So I started exploring the notion of like, okay, so if all of a sudden, right, we don't have power, and that's not like a call to arms for preppers or tinfoil hat folks, something like that. I'm just thinking through this, right? I don't. It's going to happen tomorrow or anything like that. But it's a fun problem to think through just from this perspective, right? So I started thinking through like, okay, well, what's the basic number of concepts that like the average person would have to know to get things done practically with electricity. So I started exploring that a bit, and I started working on a project called Practical Post-Apocalyptic Electronics. And so one of the practical exercises in this was called the shack. And this is a 6 by 11 foot shack in Kentucky. And I went and I stayed there for a week. And it doesn't have electricity or anything like that, electricidad. And I took with me a bunch of stuff that you might find in a typical American house, right? I had a coffee maker, I had a couple of yard tools, some other stuff like that, just regular old stuff. Spent a week taking it apart and like starting to retrofit this shack with things that are kind of necessities, right? So this is actually my initial approach to the shack. My grandpa built this for me when I was like 10, so it's been a long time since I've been in it. Spoilers. Yes. Open. Okay. It was the only way to be sure. All right, I didn't burn it down. I spent like 2 days cleaning it though, thoroughly. And then I took and I tarped out the whole inside like Dexter's Kill Room. And I took like 37 bottles of that spray foam and like literally made the whole thing a boat. Like, it could have flooded outside. I wouldn't have known. Yeah, so I started working on lighting. I took a full bottle of water, which acts as a diffuser if you put a light source next to it. I took a little tchotchke LED flashlight, popped the lighting element out, and fixed that to it. Doing some soldering with no soldering tools. Harder than it sounds. I used a blowtorch for a lot of stuff. I ended up basically taking a nail between two pieces of bark acting as an insulator. Some pliers would heat that up to his blue. I'm so sorry. So it was blued out. Then I'd take that and use that to heat up my work, and then solder. Very slow process, but interesting and can be done certainly. But ended up with some interesting lights in my little shack. Made it nice and cozy. As far as power goes, I had a 12 volt ATV like marine battery. I was also using it turns out, like just through the process of experimentation, I found out if you run roughly 19 volts through this one wall wart that I had, run it backwards, it outputs a fairly steady 5 volt signal. So like, okay, well, that's a thing. So like I could use these batteries you would find in drills and stuff like that. Also a USB. So I figured that if this thing went sideways, we'd have a balls ton of those little USB battery packs things. So I wanted to be able to use those as well. So that's actually just a like cigarette lighter 5 volt adapter from a car. And so I could, hot swap out, these 5 volt battery packs, and then that would run into this. And this was sort of my main like control board for everything. Pause for.
Understand how awesome this is right now? This is really awesome.
Do I need to sound more excited about it? This is my control board. That came out more anime than excited, I think. Scoot. We're getting there. Well, it's small compared to a tactical nuke, which is why I started. So yeah, I used a variety of stuff. Obviously, like there are much easier ways to go about this. These three things here are actually switches, and they do various functions inside of the shack. And so like I used a relay from a thing. I forget where I pulled that out. Relays are freaking amazing, by the way. Relay, you guys familiar with electromagnetic relays? So like if you're in your house and the AC cuts on, how do you know? It clicks, right? You hear that click? That's a relay. It gets cold. Thank you. See, was that Occam's razor there? Like, he and Rorschach are going to come burn this place down. So yeah, these relays are in a lot of stuff. Anything that it clicks, basically. Some of your like big flat screen TVs have this. Your fridge has probably got one. Actually, the place where you could very easily find these things are in your car. You probably have like 5 or 6 of them just in your car, right? That's the thing that like a relay basically allows you to have a low power switch to turn on your headlights, and then direct like a more high current line through your actual headlights, right? So I'm not going to go into how relays work, but like if you get into it, basically it's like an if statement, right? If I'm supplying power to the relay, it's going to connect this lead to that lead. If not, it's going to connect this lead to that lead, right? So if you think about that, like you could start building logic gates, you could start building anything, right? You could start building CPUs. This is how it started, right? But much smaller. This is just an example of a switch. It's kind of gangster. You close the latch on the lock, and it connects this to this, and you have to turn the key to turn it off. It's kind of fun. Like oh frick! You'll see why it doesn't matter soon. So yeah, I pulled this little leaf switch out of this blower, and tacked that up to the door. And that allows me to be able to have the light automatically turn on when I enter. And I even went so far as to put a little status LED on the board. Is my door? Oh, yeah, it is. It's open. I know because bugs. In Kentucky, right? Oh man. So I wanted an alarm as well, and of course, because I never be too careful. Never be too careful. But I wanted to build what's called a latching relay. Basically, once you put power to this thing, it doesn't, like, when you take power off, it doesn't flip back, right? It sticks. There are some very simple ways to build this. I went a not so simple route, rather intentionally for the fun of it. So I took a head unit out of my car, and I'd replaced it not too long before that. And I used a little CD ejector, motor assembly thing, that little gear assembly. I took that out, and all the stuff in your car typically runs on 12 volts, which is nice because it plays well with marine batteries and stuff like that. So, that was a video. Cool. All right, so that was the latching relay actually working, and I'll explain it. So basically, when 12 volts hits this little motor assembly, right? This motor, starts, turning these gears, and this knob starts spooling up this trot line. And once that slack gets taken out of that trot line, it yanks this little plastic tab out of between these, what is this? Clothespin, right? And on either side of that clothespin, on the business end, are 2 leads, which connect, the circuit here. These 4 9-volts, which run down to the weasel that's mounted on the wall. So, who knows what happens when you run that much voltage really quickly through a really thin wire? It acts as a resistor, right? And starts heating up rapidly. It starts shedding some of that energy that it cannot possibly pipe through its tiny little body. So that's wrapped around the fuse. So now, if someone opens the door and our little master lock is shut, right, that circuit is closed, that's going to supply power to our latching relay assembly gangster thing, and then this will happen. Listen, the takeaway is set fireworks off in your home. That's it. Just I can say that because I'm not the police, but no, really though, set fireworks on in your home. It's a good time. It smells fantastic. It smells like youth, right? It's like when I was a kid, like that smell, it comes right back. It's fantastic. So, all right, so I spent a week in the shack. Having done that, I reflected on it, and while it was definitely a learning experience and very beneficial, I kind of thought that maybe the scope was a little broad, right? So using anything and doing anything with it ever, it felt a little, it was tough to digest all that, right? So I kind of wanted to look at take more of the Cuban driver motor approach. Like if what happened in Cuba happened here now, what would be our washing machine, right? What would be that thing? And so Brian would be the thing. I don't disagree. But I started thinking about the Keurig, the coffee maker, right? Specifically, I'd taken one apart not too long before that. I don't know what that was. Amazing, but there's a lot of really good stuff in these things, right? And so I started looking at that, and I read some statistics, and middle of last year, I think they put Keurigs having been in nearly 1 in every 3 homes in America. Something is still happening. It's like a video playing. I'm just going to go back for a second. Oh man, that was forward. All right, so anyways, some ghosts in here. So yeah, I started looking at the Keurig. They're everywhere, right? And these things, they do have their mechanical problems like anything does. And so what you'll have is this device that has a lot of potential inside of it, but a lot of them will get turned over. People will replace it with a new machine or whatever like that. So so I started looking at that. Like what's the full potential of a Keurig? And so I started buying them on Craigslist and other places and tearing them down just to kind of do some experimentation and sort of figure out what was what. So this is tearing down a brand new Keurig. Taking my time and being careful, it takes about 2 hours, and I sped it up a lot here. Make sure you take time to play drums on the Keurig box. So yeah, a couple hours later, you've got everything nicely disassembled, not breaking anything intentionally. And what you'll find in most Keurigs, and like the actual parts inside have changed over the years and over various models, but things that you could pretty much more or less guarantee are going to be in there are things like an LCD assembly, which for me and in my purposes is not terribly useful, but you've got a lot of really nice components that are typically through-hole soldered onto a board and usually nicely labeled, which is nice if you want to repurpose those. You'll find a mesh of these ribbon cables. You'll find some of these transformers. These little, a lot of them will have discrete power management, boards for taking in the 120 volts AC and then converting that to whatever the Keurig needs. They'll have a boiler in it, various shapes and sizes. They'll have enough rigid and flexible tubing here to choke a donkey. A variety of springs and rods and screws and metal parts and stuff like that. A lot of them will have a pump of some sort. Now this particular one, I think I pulled out of one of the View models, the Keurig View. This is a really, really nice piece of hardware, right? So it's a stepper motor. It has a built-in electronic speed controller. So you give it a supply voltage, and then you can give it a pulse width modulated 5-volt signal to say, well, how fast is it going? And then another one you pull to ground to say, is the brake applied or not? And then another one you say, oh well, if this is above a certain number of volts or a measure of voltage, then it's forward. Otherwise, it's reverse. It's got it has a built-in Hall effect sensor, and so you know exactly how much that motor is actually turning as it's doing its work, which is fantastic. And very well documented part, absolutely outstanding. I was a little disappointed to see in the newer models they switched from the stepper motor to like I guess a probably much less expensive regular brushless DC motor, but they still had this really nice they still had this really nice gear assembly thing, which basically converts that rotational motion into a linear push and pull, and they use this to pump water out of the reservoir, into the boiler, right? Fantastic. You will find pumps that pump air, pumps that pump liquid. This is a 12-volt solenoid, right? And so like there's a lot of other stuff, really kind of depending on which one you're looking at. But what you could pretty much expect to see is sort of that list of things, more or less. Some of the new ones they don't use solenoids anymore. It's been really cool to watch how the design has kind of evolved over time, because they're using less and less parts, less and less complexity. So like if you guys ever like want to get an appreciation for engineering or like manufacturing, take stuff apart, right? And like the process of doing that, you have to think through how someone expected for someone to put this thing together. It's really interesting. But I wanted to learn about kind of like the basic operation of a Keurig. So looking at this, you'll typically have a control board and the boiler, of course. And here's a solenoid. Like there's a pump down there, and like water gets piped in from here, and it goes. You know what? It's all witchcraft. I don't even know. It doesn't even matter, right? For me, like I wasn't trying to build another coffee maker. I was trying to build other stuff, right? So if you think about like all of that stuff, all of these components, right? And you try to solve the problem of what's the full potential of this thing? What can you do with it? The answer very quickly becomes, well, pretty much everything, right? Yeah, that's a really good question. So the question was, as the design progressed, did the components get cheaper? They probably did, but in intelligent ways. So like, I'm trying to think of a good example of this, right? So like, okay, here's a good one. So who has a Keurig in here? Show of hands. A few people. So like once the water in the reservoir drops below a certain point, right? It says, hey, you need to add more water, and it blinks like a VCR, right? Did you guys know how that works? So basically, in the reservoir, there's this little floaty thing, right? And it floats with the water level. And once it drops below a certain point, a reader on the other side, either magnetic or some of the newer ones actually have, like the floaty thing is a half circle, like spherical, that's the word I'm looking for, reflector, right? And it reflects just an infrared light back, and it says, okay, well, you were here. The newer ones, they removed all of the moving parts, and they basically just have, alongside the reservoir, a thing that funnels up, and yes, please, and they read the water level at various points, right? So they just have 4. Thank you. Oh man, I love Woodford. Cheers, everybody. So, thank you. So yeah, so in that case, they probably saved a lot of money, right? Both in manufacturing and the actual parts themselves, but they put a really intelligent, really smart solution in place. So that was just like pure engineering. And yeah, so that's a fantastic question, though. So when you start thinking about potential, like you can go either way with it, right? So you have like, well, what are some positive things I can do with this thing? And also conversely, what are some negative things that you can do? Well, I started looking at the negative things first. So kind of the first thing I wanted to do is set up a bit of a test rig and kind of play around with some pneumatics. I wanted to be able to transfer liquid from one place to another, right? So like if I had a reservoir, I wanted to be able to fill that up back into the boiler, but do it, with my own microcontroller and all my own setup and all that stuff. So I got this whole thing set up, and the boost gauge there is from a car, and you're probably imagining what I wanted to do with that. And just as a quick aside, like show of hands real quick, how many people assume that if you have a boiler like this and a product like this, when that boiler is boiling the water, that it's under pressure? Reasonable assumption? I mean, I thought that going in. But actually, no. Like when the Keurig is on and like that boiler is heating up the water, it boils into the atmosphere. So like there's relatively no risk of, like overloading the boiler and all that stuff. Not to mention that the boiler itself has a thermal cutoff like directly on it, has another thermostat right there on it, in addition to a thermistor, which is feeding back into the board. They're actually relatively safe from a physics standpoint, right? Not quite safe from people taking them apart and building fun things with them. But so yeah, I wanted to do a test where I basically transferred water from one boiler to another. You might call this reloading. I don't know. Cool. Worst video ever, right? It made a sound for a second and then it was done. Amazing. All right, so in this one, I basically flipped all the solenoids on and supplied current to the boiler. And you could see here, as that water converts to steam into this thing, that pressure is steadily increasing. And so once it got to a certain point, I went ahead and sent 12 volts to a solenoid, and then released that out of another tube. So you may be thinking, well, if you're here at this point, you have the ability to release a lot of pressure inside of one direction, and control that. Like, what do you have, basically, right? Well, I was going to say firearm, but but yeah. So I started thinking about that, and then so I kind of just switched gears here in the middle because I found, like, I've got a 2-year-old at home. I found the only time I could work on this is like literally the middle of the night, right? So I'm in the garage and I'm not sure if I'm going to blow this thing up at any moment. It's a bad scene, right? And also, I kind of thought that it was the low-hanging fruit. So I switched over and I started looking more at the positive things that you can do with this stuff. And I wanted to pick a project that sort of showcased like the various components and what you can do with all that stuff. And I wanted it to be ambitious, right? So this is something that I'm working on now, and I want to show you the progress and kind of the steps leading up to it this evening. But I'm building a mechanical prosthetic. So this particular one, you probably paid 90 to 100 grand for, right? These things are terribly expensive. And the other reason I picked this is because there are other people actively working on solving this problem, but doing it in like hacker ways, right? So like 3D printed prosthetics is a substantial thing now. Like that's a viable option if you need to have a prosthetic like this. And so what I did was basically what all of you should do if you start working on projects and you're kind of unsure of the direction to go in, you start making some garbage prototypes, right? So this is the first one. That I just wanted to kind of test, like, some of the mechanical bits of it and see how all the stuff would work together. Really, the mechanical part of this is sort of the only tough problem to solve. Not completely tough, but not the only one. But it is definitely, far and away the hardest, right? Because you want to have, fairly good control of this thing. You want it to be able to grip something, right, with a reasonable amount of strength, and do that with a very simple, like, linear motion with, like, whether it's human powered, like a lot of them are, or whether it's powered by, like, I don't know, a linear actuator, right? Like the ones inside of a Keurig. So, started doing some tests with this. And this was very valuable for me because I started learning about, like, limitations of the materials I'm working with. How does this plastic hold up? How can like these various, like, metal bits be used effectively and all this stuff? And so that's sort of like, this is sort of Iron Man when he, like, first built the suit to get him out of that prison in the, like, cave, whatever, all goofy looking. In retrospect, it's like, oh, big dumb thing. Like, that's this, right? So, but it's early on. So then I moved to just testing the digits and the particular mechanism I was going to use for those. So I went to this, like, freaky, like, worm sort of thing, where I'm using a piece of rubber from the tubing, cut it open, and then tacking that along the various joints, right? And so supplying a force on the side opposite would cause it to constrict, and then the elastic would return it to its original position. So I found that there wasn't enough horizontal stability with that particular model, so I tried another one. Same basic concept, using 2 lines instead. And so making progress, right? You know, we're getting a little further along. And so from here, this was, I guess, about 3 or 4 weeks ago. I thought, you know what, I feel like I'm in a fairly good place. I sort of know what I want to do, so I started recording a build from the very start, and I'll show you that now, actually. And this is actually this is going to be 20 hours of hands-on work, right? I've seen this. Hold up. This is the wrong video. I probably shouldn't have been drinking earlier. We will fix this. Can't fix it in post. We'll do it live. Okay, here we go. Literally using a heat gun to mold plastic to create these parts. When I say 20 hours, I don't mean like time thinking about it or like sketching really or anything. Manipulating materials, basically. I have no idea what this music is, by the way, but it's god awful. I'm sorry. I was like, that one. Sounds like a cat playing the guitar. This is easy. Noise. Oh man. Totally different. This thing right here, this is the water level indicator that I was talking about earlier. At least I think it is. Someone is learning how to play the guitar right now in this song. Chord progression. Getting better. All right, cool. So that was a brick. So I'm forming each of the finger pieces at this point. Actually, the little metal rods that were used to I guess capacitively detect the water level, I use those as pins and joints for the fingers. And that was a great suggestion, by the way. Thank you. What am I doing here? I don't even know. So yeah, so I did a crap load of just filing away. So like when you do like inexact stuff like this, where you don't quite know how things should fit together or will in the end of the day, you tend to leave more material than you need, knowing that you can trim it away later. So there's a lot of that going on right now, to sort of like fine-tune things and get things right. A lot of sanding. Here I think I'm just like trimming down metal rods. Let's see. Wow, this video is longer than I remembered. I say remembered, but like this was this morning, so I should remember. And it may be, I don't know. I hope not. How It's Made, like one of the best shows ever, right? So just doing some assembly here, like actually putting the fingers together. I think this thing's only like 5 minutes long, so we'll probably creeping up on the end. Let's see. Yeah, starting to come together. Yeah, sorry about that. What? Can you clarify? Can you clarify the question? Or rephrase? So I'm actually using wires from a ribbon cable as my fixed rigid wires. OMG. All right, so I think the music gave up. It was 20 hours, yeah. I mean, not 20 hours of this. Oh, no. So anytime I would approach, my setup was crazy. Like, I had a tripod, like, mounted to the ceiling, basically. Anytime I would step up and start working or modify anything on the desk, I would start recording. If I stepped away to, do whatever, I would cut it off. So this should just be hands-on time. Cool. We're getting close. Is it though? Is it what she said? All right, cool. So, I'm not going to repeat that for the recording. So the silky smooth motion, the natural finger motion. Hey. So yeah, believe it or not, to make this out of a coffee maker, it takes a lot of time. And a little trial and error, turns out, and some really awful cat music. Cats playing guitar. Cool. All right. So yeah, bought a Curate. Well, I mean, overall for the project, I've really hands-on. We're stretching now, are we? I think I've probably. Well, you're not wrong. I probably picked up 5 or 6 Keurigs total, just on Craigslist and stuff. Oh, very much. So, I mean, that was the only one that I bought new, and that one was, there was a special at Target for like $100, right? So all that stuff. So yeah, you're looking at $100 at the most there. So yeah, next up for that, going to add a thumb for that guy. He needs one. Probably take the same approach. And then, just kind of wire it up to, to sort of I'm going to use kind of a pivoting bar, essentially. And that will provide the linear force to actually, close the fingers and open them, right? And so I'll connect to the other side of that at, various points along the pivot, right? So it's adjustable, essentially. I'll connect that to that pump, that linear pump. So that thing will allow me to open and close a hand electronically, which would be pretty sweet. And after that, I'm planning on using the there's a number of ways to do this, right? So what I want to do is be able to, instead of just being open or closed binary, be at any step along the way. And that's sort of tough to do when you're dealing with that kind of system, because you don't know with this particular motor, like with that last stepper motor that I pulled out of the old Keurig, and I'm just using new ones from here on out. You would know exactly where you are in the rotation, so you would know exactly how far you've contracted your fingers, right? So now I sort of have to solve the problem a different way, and I'm planning on doing that, a few different ways, but one of them, at least one of them will involve using the color sensor that Keurig is using for DRM. So it'll actually be useful, like a useful piece of hardware. Also, the water level sensor, and there are actually a couple of magnetic sensors in the newer models too, just to make sure the lid's closed and all that stuff. So I'm planning on seeing if that outputs an analog signal, or some some non-binary signal. So yeah, so that's kind of where I am with this right now. So we'll move to takeaways real quick, and we'll get out of here and we'll start drinking. Because yes, I'm over on time. Cool. How do we make the crap we buy more MacGyverable, right? If not for us and things that we want to repurpose it for perhaps for other people who don't have the stuff, right? Instead of sending this stuff to landfills or like getting directly recycled, like, I don't know, like, is this a thing that we do on the manufacturing level, or is this a thing we do on the individual consumer education level? This is a fascinating thing for me, right? I wish that products that I buy had like a MacGyverability scale associated with it. Like how easy is it for me to take this and like repurpose it, or how well documented is the PCB and all this stuff. Like it's interesting stuff. It's a pretty big question. So Ben. I have no idea. Yeah. No, that's a question for a greater mind. My last takeaway, actually, I'll do a little backup story, and I hope this comes across the right way. We'll see. But we'll rewind to 2006 real quick. I'd seen the movie Death Becomes Her, and it was the night before Halloween, and I wanted to make a costume for my, I was employed at Trone Advertising at the time, and we were doing a Halloween party the next day. So I wanted to make a costume, and I had this idea, and I wanted to try it out. So using like a bunch of busted stuff I had, I built this, which is, I called the gaping hole costume, right? This is my gaping hole costume. And essentially I took a lot of duct tape. And this is before iPads or, fancy phones and stuff like that. It's 2006, right? I had a travel DVD player, like little screen thing from a friend had, but had video in. And I had an old digital camera, and the battery was shot on it. And actually I think the sensor was kind of going bad too, excuse me. But, so I cobbled this thing together, took a couple of hours, and I made the gaping hole costume. And, it was a thing, and we went to the party, and it was fun and all that stuff. But fast forward 2 years later, 2008, actually the costume, it trended on the front page of Reddit a few times, and like got some views and stuff like that. And I hosted it on Flickr, because we used Flickr in 2006, I guess. I don't know. Yeah. And I sold this. It was a girl named Nicole took the idea, the concept, and like took it to a whole new level, right? Made this amazing costume. Actually, put some craft behind it. It wasn't like a white white sweatshirt. And by the way, that is the only acceptable use case for a solid white sweatshirt. And a blue wig thing, Dr. Tran.
So back in like the 40s, 50s, like every piece of electronic clock, basically had a diagram of how it's built, how to get an estimate. Do you perceive, based on the work that you do, that will make creative with your database where every electronic device that you buy, people like you, take apart, document how it's actually put together so that it can happen? Is it China already doing that?
I think that would be really cool. I don't think it'll happen. What I think might happen, I mean, I think so. What I think might happen, it wouldn't happen on the component level so much as it would like the functional group level, right? So like an example might be the, yes, so the question was, oh shoot, how do I repeat this question?
back in the day,
Ah, right. Yeah. So old electronics, they had a diagram, and it helps you actually understand how it works, right? And it like, do I foresee that happening, or some kind of like collection of knowledge that's probably user contributed that would exist like that for products today, right? So I would say maybe for cases like the DVD ejection assembly thing. That might be easy enough to integrate that into another piece of functionality, right? Something like that, maybe. I don't know, but it's tough to say. But anyway, so yeah, she took this thing, ratcheted it up to the next level. Great question, by the way. And that was all fine and good. Fast forward to 2011, the iPad is around. A NASA mechanical engineer named Mark made this costume, the gaping hole and torso costume. I don't know if there's any similarity here at all. He's following the white sweatshirt rule, which is good, but he did a fantastic job with it. And 1 year later, he has a company called Digital Duds, making shirts where you put your screen devices in them, to make really interesting costumes. Fast forward a couple more years, he's actually merged companies with the guys who make those morph suits, like the solid colored freaky people suits, right? And he's got these amazing masks and a whole line of shirts and costumes and stuff like that, all with the same principle, right? And so this is not me, certainly not me, taking any credit whatsoever for the success of this, right? Definitely not. But I no, I'm trying to put this delicately, but like I think I'm able to ask the question is if I didn't spend a couple of hours one night in 2006, like would this have happened, right? Which, the answer to that question doesn't matter categorically, but I'm proud and happy to be able to ask it, right? And so I'm very happy that's how I chose to spend my time in 2006. And even though I don't think anyone cared at the time or whatever, I think that it probably did impact someone on a very, very substantial level. Right? So I guess my final takeaway would be this. You don't have to change the world to establish a precedent, right? Like if you do something, you don't have to have 1 billion views on YouTube for it to have mattered, right? Be it now or in the future. Right? It doesn't have to be something that revolutionizes an industry or something that brings you a lot of wealth or whatever, right? Like your little quirky, you got too much time on your hands project that no one understands why you're doing it, right? Like that thing, it doesn't have to change the world, right? It just has to be done. You just have to do it. That's the only requirement. You have to do that thing. Like the difference between a thing that's never been done before and something that's been done is you doing it, right? And if it's something that's interesting, and I would venture to say that we're probably a pretty interesting bunch. I don't know, to me, this is just like we should be building, fervently. Don't ever stop doing that, right? And the reason for that is because everything can kill you. And we're all going to die pretty soon. And although I think most people probably assume that the number of people that are influenced, right, or inspired by yourself at any given time is hovering around 0, it's not always the case, and you never know. So don't frickin' stop building. Always build stuff, right? We're all going to die. I'm going to die, but I'm going to build a lot of crap before that, unapologetically. So that's the takeaway. Thank you very much. I'm terribly over time.